today. Uh, but before we start, Bob, I wanted to ask, does anybody have anything that they'd like to squeeze in today? Because otherwise we can give Bob the floor for the rest of the activity today. All right, I'll take that as a no. If you change your mind, you're out of luck. This is it. All right. Bob, introduce yourself and start from scratch.
Okay, I'm me, and I guess are you seeing my screen now? My 4K screen? Guess so. One of the things is
it's working fine.
Cozy. What? Yeah.
We
Cozy.
see your screen. We see your
Okay.
screen working fine.
Let me start with hitting F11 to put down starting time. Cozy, and I'd like to have all this. I hope this is all big enough. I think it is from previous, but Cozy is my notebook. It is my Jupyter notebook, and it's built in well, Riva 4th, but it's APL level vocabulary. Actually, I think that it's far more flexible than any traditional APL. But a couple of notes that I made along the way with the mention of some statistics. Let me go and open up another window and just show you what the statistics. This is some of the math functions and so forth that I have. And by the way, I'm waiting for Tau Day. I know we just recently had Pi Day, but you know, Tau completes the circle. This is actually, some of these are fairly old, but one of the things is I thought it was kind of useful to show what the size and so forth, how succinct definitions of like covariance and correlations are. And this is slightly old code, so hopefully be a little clearer. But some of these mechanisms I'd like to go through in some stuff I've done recently. And one of the things is you'll see when I execute a line, I'm F6ing it. Essentially, if I hit enter, it just is words. Now, one of the things that I said I would talk about was this Martin Gardner's game of Bridgit. And is this over here in my, this was the original thing. Let me go get even bigger on the thing. A mention of Martin Gardner was done by this guy. I guess I know him through APL really, but he's clearly a polymath. But I subscribed to Scientific American when I was in high school, so and Martin Gardner's mathematical games. Are any of you familiar with Gardner and mathematical games? I mean, that was definitely a great old series. And Gardner, well, his book, Fads and Fallacies in the Name of Science, was a rather famous book. But he described a game named Bridgit. And I think, as a matter of fact, I went and I already have, whoops. That's that one. That's the, well, let me just, I actually have over here, Control F6. Let me pull it up in this window here. This description of the rules, which for some reason, I don't know whether I hit a wrong key or what, but let me, this is this game of Bridgit. And what it is you have the reds and blues, so it ends up being a maze. And one player is trying to connect a line from top to bottom, and the other is going left and right. And I'd read this in Martin Gardner's, in high school. And then when I got to Miami, Ohio, their computer, the school's computer, was an IBM 1620. Is anybody familiar with those computers that old? Its nickname in development was Cadet, for Can't Add Doesn't Even Try, because it actually went and did arithmetic by table lookup. So you can imagine how slow it was, and they had an extra box of an extra 20,000 decimal digits. It was all BCD, and but I really interacted it mainly through a lightweight Fortran. But one of the first things that I tried to do was to solve this Bridgit game, and I'm putting this out for future challenge, because actually at this point I can't remember even how I represented the board. But however I did it, it was relatively easy to make the moves. But the question I ran into is, okay, how do you know when you have a connected line from one side to the other? So essentially you're going through a maze. And the thing that I really remember is that I kept running into the fact that I had to save more state than I initially did. And so when I got to Northwestern, they had one of the first languages that I learned there was Algol. And Algol had recursion. And so I finally went and solved this problem, because you have to go in maze running. You go forward, you check, okay, have I hit a dead end? Okay, and actually the simple way to do it is, okay, I try to go left. Okay, run into dead end. Okay, I try to go forward. Okay, dead end. Try to go right. Okay, well, if I haven't done that, then I back up and do the same thing on at the previous node. So that's where the recursion comes in. And I know when I learned APL early on, it just was essentially, essentially for left, right, forward, and retreat, very short functions. So that's what I'd propose as a challenge to do in fourth. And actually something that perhaps is more commercial value is when I was doing, I rewrote Xerox's worldwide long-range market forecasting system, but I was there in Rochester, and a question got asked about DHL, which is a global package company like FedEx. It turns out that each individual station in their network knew that when they received a package, where they were and going to some particular place, they knew where they would send it to. Each node knew what it did with a package destined for some particular place. But there at top management, they did not have a map of their overall system. You know, and so this is a similar sort of a thing, is okay, you've got the connections for each node. Now go and develop a global map for the whole thing. So anyway, that's what I propose as a challenge. Let's see, I showed that. I showed and we get down some bits of code that I wanted to show. Control F9 goes in. I've recently done a couple of bits of code, and I'm just gonna, this is my walk-on. A woman out east of here, by the way, we've got about 10 centimeters of snow today. And it's now up to -1 centigrade. But she had some pictures of hummingbirds, and this is just sort of a demonstration of what I keep a list of every year. I clone off my text of notes for each year, and so I took all of those, and essentially these 3 lines, I collected all those, read each of those files and go through and finds the first occurrence of hummingbird, of hum, H-U-M-M, in each of those. And so these are all of my since, 2008 anyway. Those are my first occurrences of hummingbirds. So I know I'm expecting the hummingbirds to come back, and I need to put out hummingbird feeders. But you see, April 21 and May 6th, so we're getting there. Next week, if the snow is gone, I may see hummingbirds. But one other function, and this one is important, and actually goes and illustrates a lot of very important vocabulary. This problem was posted on Facebook, and so coming over here, I did. Where is an example? Oh, I remember the examples that plus scan is or scan is what's called an operator in APL, and it takes a function. You can see here in the in my comment on it. It takes a piece of data, and it takes a function as arguments, and a brilliance of forth. And why actually Cozy, I'd put it up against any APL at this point, because it's enormously simpler. And one of the major things is this brilliant little function in forth that rather than executing a verb, it returns the address of whatever the next item is. So it's trivial to pass functions to another word. And to show a demonstration of what this scan is the word it essentially goes and executes the partial, whatever that function is. And here, this is just taking integer 1 and make 10 of them. So I've got now a list of 10 ones, and this is the integer plus. Okay, so that's the verb, and this is the scan on it. So there you can see it's each sequential one, it summed up, and if I do it again, R0 is always the last argument. So like I say, this is my Jupyter notebook, and the real core thing that really needs to be done is to get rid of this, if you will, development interface and make it just a web browser interface. And then it can start being really commercial product. Anyway, the definition of COSI is here, and it's in my fourth file. But the couple of things that I want to say, this is very fourthy. I mean, you can see, and because it's going in and it sticks that function up into an auxiliary stack, and then this word actually goes and forms a stack frame, and it stores this argument now, this right argument here, stores that, and then, okay, dupe, everybody knows, and this is the count. This is how many items there are. This, I've gone and following, can't remember, somewhere I saw a notion of this using in a minimalist programming, I guess, on Facebook, minimalist programming group. Somebody was using the $ for swap, and I really liked that. So that's swap. So here I'm pulling the type. So I've got I'm making a new vector of the number of items, and it's just zero filled to start with. And I'm storing that in loop stack. I've found that because recursive functions are so important in all of this, to have a separate stack which is used in loops, so it does not conflict with uses of the auxiliary stack or any other stack. I've got a separate stack for doing loops. In any case, it's storing that. Then one of the things is this pushing of a parameter. This is push to parameter, and again, like a stack frame. Our fetch is that right argument, and so it takes the first element of that, and it stores it in the first element of the loop stack of the object, the list that was stored on the loop stack. Then it goes and accesses that and the number of items. And here you have your do loop, and for each one, it goes in and it grabs the ith minus 1 element, and then from the original data element, it grabs the current element, and then it pulls out the verb, and it executes it, whatever that is across there. And so and then it stores that in the current loop stack element, and then it loops and so forth. And then it just drops the auxiliary, the function that was stored, and it returns that from the stack. And this capital L, these capital L words, is one of the things that I had to fix. It took me far longer than it should have to get working, but this handles the reference counting on that, and then this pops the variable and the data stack. But okay, so that's everything. But that, if you're talking in APL world, the idea that you could have a definition of an APL function, of an APL operator, or adverb is what Ken Iverson ended up. And I kind of like this notion of data as nouns, functions are verbs, and these operators are adverbs. But one final thing I wanted to mention, my thing, is we've got a group that I got to the Heartland Institute meeting last month, so I missed this. Heartland Institute, you may know, is without question the major global climate realist group, and a lot of really fantastic people get to it. But one of the things is I and a bunch of other people are looking at putting together a really solid K-12 real science curriculum and real physics, and going and actually, I mean, right now, you can either teach algal warming or physics. You can't teach both. So that's everything. And I think that, so let me, okay. And we're on the hour. So any questions, comments, blank faces?
Well, I know you don't do PowerPoint, but if you could maybe write a text document that would lead others where to look for a definition of the Bridgit.
Yeah.
In mind that this would be a challenge for next month. If you could maybe write something that would be a concise description, and with maybe a link to where to go to find out more. And we could post that in the meeting notes, Dave.
Yeah, I'm almost inclined to think, well, I don't know. They're obviously correlated problems. The Bridgit, I mean, the most fundamental thing is this issue of making a program that will work its way through a maze and know when it's found its way out the other side. But the DHL problem is really quite interesting too, and that actually is one that had a commercial application. That all these independent nodes, knew where if they got something that had its final destination somewhere like Abu Dhabi, and they're in Kansas, they know that they send it to like Chicago or whatever, but they don't know. There's no map of the entire system. So that's a rather interesting and related and actually commercial, problem.
Yeah, maybe I'm naive, but it seems like if there are 100 offices and you just send a memo to an email to each of the 100 saying, okay, send us your list of where you send stuff, that it's not a horrible master's thesis to try and distill that down to Excel spreadsheet.
Well, I haven't used Excel or anything like that. So, but I mean, the thing is, yes, they had the list. They essentially had sent that email. Oh, this was even then sent the email to. So they had the list. Each node sent them back a list of, okay, when we get a package that's headed towards such and such a place, here's where we send it. And almost undoubtedly, the list was something that went from the most local offices. It sent them to the major nodes, Chicago and LA, whatever. But they didn't have the connections. So yeah.
What,
I don't know.
Will you take this as an action item to produce a written challenge and send it to the list so that we have something for next month?
Yeah, well, I actually am probably going to be missing next month because I'm getting to my 60th class reunion at Culver Military Academy. So I'm afraid I'm probably going to miss next month. I feel like I'm in a lot better shape than a lot of my classmates who've died.